Newton's laws of motion and his law of universal gravitation also play into tides, of course. So we talked about orbits before, now we're talking about tides. It's gravity in action for tides. And this is the Bay of Fundy. I thought you might find this pretty interesting. This is at high tide, and that's at low tide. We can go back. That's high tide, and that's low tide. These are some of the broadest tides in the world. At the Bay of Fundy, those tides can go to 10 feet. Normally, tides are about a meter distance. These can go much more than that at the Bay of Fundy. So this is a real occurrence of gravitational pull of the moon. Let's explore it a little bit more. Again, Newton's third law, gravity is mutual, and both the Earth and the moon attract each other. And the tides are caused by small differences in gravitational force. Let's look into that a little bit more. It might be easy to understand that when the moon is on one side of the Earth, it can pull the water on that side, resulting in a bulge of that water. That seems to make sense. And then you would think that, okay, maybe there's one high tide per day then where the moon is on the side and it is pulling as the Earth is rotating. So maybe the side of the Earth that moves into the high tide area that is along the Earth and moon line will experience the high tide once a day as that Earth rotates all the way around once. But that's not the way it goes. And actually, there's 2 high tides a day because the gravity of the moon is universal to the atoms of water in the ocean and the atoms of the soil on the land. So the moon is not only pulling on the water on the close edge, on the near edge, but it's also pulling on the land of the Earth. And in fact, it pulls it over just so gently over that it leaves space at sea where there's water that builds up there as well. Because now, let me move this back, you've seen that the Earth was moving over with the moon. It moves over and leaves some space at sea for another high tide. So there's actually 2 bulges by the draw of the moon. Now, it's very dependent on distance. Remember, we said that the square, the inverse square of the distance, says that closer objects have more gravitational pull and objects that are farther have less gravitational pull. So this center of the Earth that's being pulled by the moon is going to have less movement and less gravitational pull than the water that is on the perimeter of the moon. All right, but still the center of the moon does, the center of the Earth does move with the pull of the moon and expose out another bulge of water on the other side. Why are there 2 low tides every day? Well, remember, the Earth rotates into the tides and rotates into the low tides as well. And what you're seeing there is the Earth-Moon line. And of course, the moon is attracting the Earth, and the Earth is attracting the moon. And as the moon attracts the Earth, the acceleration of the moon towards the acceleration of the Earth towards the moon moves along that line. But at this point at A, the acceleration of the Earth towards the moon gets directed away. In other words, it's not a direct line between the Earth and the moon. This is an angular line between the Earth and the Moon, and the water along that line gets directed away toward the Moon. It results in a downward force at these areas of the Earth, so that the Earth has two high tides, one at each position along the Earth-Moon line for high tides, and low tides perpendicular, again, as the Earth rotates in and out. In addition to that, you can have spring tides, which are extremely high tides and extremely low tides. They're named spring tides not because of the season, but because of the action of the tides springing up so dramatically. And it happens when there's not only a Moon-Earth line, but a Moon-Earth-Sun line. So when the Moon, the Earth, and the Sun are in a direct line, there's more gravitational pull. Again, the Moon is the predominant force for tides, but the Sun still has some pull to it. And at the full moon, when the Moon gets the direct sunlight upon it, and at the new moon, when the Earth can't see that sunlight, these are still examples of the Moon, Earth, Sun line that produces spring tides, which are very, very high tides that occur at the new and at the full moon. Correspondingly, let me move this down, there are neap tides. And neap tides actually comes from an Old English word that means no power. And neap tides are very mild tides that really have a perpendicular trend to them that negates the overall impact of the tide. So for instance, when the Moon-Earth line is in perpendicular to the Sun, in other words, not at full moon and not at new moon, but at first quarter moon or at third quarter moon, that means that this evens out to a very mild tide. There's a mild tide along the Earth-Moon line and a mild tide along the Earth-Sun line. So that happens at first and third quarter, and they're called neap tides because the power of the tide is partially canceled out. For this chapter, we've gone over a lot. So go over these definitions so you feel good about them for the quiz, and go over the fact that the early astronomers believed that the Earth was the center of the universe and that heavenly bodies revolved around the Earth. That goes back to Plato and Aristotle. But people like Copernicus, Brahe, Kepler, Galileo, they independently and collaboratively move society toward an evidence-based scientific revolution that looked at the universe as heliocentric with planetary orbits. So in other words, these scientists worked independently, but they all read each other's work and built upon it. So they worked collaboratively as well. Newton took all of this work and explained how the universe works in terms of gravitational forces being mutual and universal. So big revolution here. We'll be talking about this throughout our course, and I will see you at the lab.